if m, p, and t are distinct positive prime numbers, then m cubed times p times t has how many different positive divisors? That means factors greater than 1. So maybe the best way to illustrate this is to just use any example. So let's say our only rules are m, p, and t got to be distinct, so different prime numbers. So let's just say m is 2, p is 3, t is 5, our smallest possible prime number. So in this case, m cubed will be 2 times 2 times 2, p will be 3, t will be 5. And so how many factors can we make from this guy? So all of our factors can be made from these numbers. And so you can either just count them all out, so 2, 3, 5, and then start making combinations of these guys, 4, 8, 6, and then you can do this until you have them all. Or you can think of it like this: our total number of factors will be equal to a plus 1 times b plus 1 times c plus 1, where a is our number of 2's, b is our number of 3's, c is our number of 5's. And so the reason we're adding 1 here, because I think of this as saying, it's like a combination question. How many times can I choose a 3? And how many times can I choose how many times can I choose a 2? How many times can I choose a 3? How many times can I choose a 5? But this isn't 3 times 1 times 1, because you actually have 2 options. You can, so for my 5, I can choose it 1 time, but I could also choose it 0 times. So there's 2 ways I can choose my 5. For my 3, I can choose it once, or I can choose it no time. So that also has 2 options. And for my 2's, I can choose 1 2, I can choose 2 2's, I can choose 3 2's, but I can also choose 0 2's if I want. So for example, 3 times 5 will be a factor here. So 15 is a factor of m cubed times p times t. And that would be an example where one of our factors that doesn't have any 2's. So I have 4 options for the number of 2's I can choose. So this will be 4 times 2 times 2, and that will be 16. Oh, and then we got to take out a 1. I was so worried for a second. So they say greater than 1. So within this 16, there's an option, remember, where we chose 0 2's, 0 3's, and 0 5's. And that option, though, that would be the factor of 1. So our real answer is 16 minus 1, which is 15, D. Or you can try just writing them all out, and hopefully our answers are a little bit spread out. So once you're over 12, you could probably see that there's not enough to get you to 27. The answer's got to be D.